Hello, hello, hello. Hi, guys. I hope you're doing well. Um, sort of feel like I'm recording myself, but it's neither here nor there. It's just one of those weird things that happens from time to time. We are going to be talking about Lecture 8 today, and this is aqueous solutions. So we're going to be talking about the chemistry of aqueous solutions, particularly precipitation and acid-base reactions. We'll probably split this into two major components, the precipitation reactions and the acid-base reactions. So that's our goal for today. Let's go ahead and get this knocked out, and let's see where we're going. All right. So we're going to talk about aqueous solutions. We'll talk about electrolytes and what those are. We'll talk about acids and bases, and we'll talk about precipitation reactions. Okay, so those are four major topics. Before we do that, we're going to talk about a couple of review things. So gold reacts with chlorine gas to create gold-3 chloride. How many grams of gold-3 chloride are formed if 1 gram of gold is reacted with 2 grams of chlorine gas? Okay, so let's talk about how we do that. Let's go back through our steps when we do this. So gold, now remember, when we talk about gold, we need to pull over our periodic table and be able to remember where gold is. So if we come down here and we look at our periodic table, gold is right here. He's Au. So Au is going to react with chlorine gas, and chlorine gas is Cl. He's one of those diatomic gases. Au, by his placement, is a solid. He's one of our solid metals. Okay, so those two are going to react, and that's going to give us gold-3 chloride. And that gold-3 indicates that we have an Au3 plus and Cl minus, and when those come together, that's going to give an AuCl3. So I'm going to erase this part because I wrote that down just so I know what those charges were, and I'll put that AuCl3. Okay, so that's what I'm going to write there so that I know what my formula looks like. Because again, if it's an AuCl3, I know that that's a metal to nonmetal bond, so I know that formula is dictated by the charges that are on it, so that's going to tell me what that looks like. And chances are that's a solid. I don't really know, but I'm going to guess that that's solid. So that's the reaction that I'm looking at. Now again, it is not important that you know that those are solids, gases, whatever at this point. It's just that's my habit. So I'm going to go ahead and write that down. Now, how many grams of gold-3 chloride, how much of this stuff do I get in grams if I have 1 gram of this gold? That's 1.00 grams of this gold are reacted with 2.000 grams of the Cl2 that I start with. And I always write this way so that I've associated the mass with each of the materials that I'm starting with. That keeps all that information together for me. I write everything down that's in the problem so that it's associated with that balanced equation that I've written. And that way I don't have to look at anything in words again. I can just pull it from that equation that I've written. Now that I have that written that way, oh, I'm sorry. I hate it. I swear to God, every time I get on camera, I start yawning. I'm going to start with the first one that I wrote, and I'm going to say, okay, I have 1.000 grams of AU. And I know that I want to go, and my general process is to go from grams to moles to moles to grams, right? That's my process for solving these problems. So I'm in grams of AU. I want to convert to moles of AU. So I need to look at this periodic table again, and I'm going to pull this up over here so that I can then put this over here and work side by side. So 1 gram of AU, I know that AU is on this periodic table here, and I can't really see that, so I'm going to see if I can zoom in a little bit. So let's see if I can view and zoom, get that a little bit bigger. Nope. see if I can zoom. I'm not going to be able to see the whole thing, but you know, that's all right. I just need to be able to read it. Although I could scroll down, but that's okay. I want to see that mass. So it says 196.967. So 196.967 grams per 1 mole. And that would cancel my grams, and that would get me into moles of AU. Now, if I'm on the test and I can't see that, then I can scroll down and I can look at this table that's down here. I can find where gold is. I should have looked because I can't remember what gold number is. I should have looked. Gold is 79. So I can come down here and find 79. Gold is right there. So 196.967. So again, that's written there so that I can read that better than I can on that periodic table. So that will give me the moles of gold. Now I know how many moles of gold. If I do this math, that'll tell me how many moles of gold that I have. I don't want an answer in moles of gold, though. I want an answer in information about gold chloride. So I know that I'm going to have to get out of moles of gold to be able to do that. So I need to know how many moles of gold are in this balanced equation. And I can see, did I balance this? No, we did not. So I need to go back and I need to look. Now there's 1 mole of gold here. There's 1 mole of gold here. There are 3 moles of chlorine on this side and only 2 on this side. So that's not balanced. So I need to put 3 out in front of that and a 2 out in front of that. And if I do that, now my chlorines are balanced. Now I need 2 out here. So I have the same number of golds on both sides, and now I have the same number of chlorines on both sides. So that means that there are 2 moles of AU used to make 2 moles of AuCl3. So if that's true, then I've canceled my moles of AU. Right? Should be 1-to-1 parity, but I had to make sure it was balanced. Okay. And then for each mole, 1 mole of AuCl3, the mass of that AuCl3 I need to calculate. So my mass of AuCl3 is going to be based on the mass of the AU. So again, that mass for gold is 196.967, 196.967 plus 3 times that Cl. And of course, I have to come back over here on this side and find Cl. He's up a little bit. Cl is right here, 35.453 is my periodic table. 35.453. Now I need to make sure I'm taking the masses from the same column. So since I'm looking at this periodic column, not the Alex column, that's what I want to work with. So since I used the periodic over here for gold, I need to use the periodic up here for chlorine. Okay, so same mass. So the mass that I calculated for the AuCl3 is 303.326. So 303.326 grams of AuCl3 per 1 mole. Okay, so what I'm doing here, what I always do is I calculate the mass for 1 mole of AuCl3, and then I use the stoichiometry from the balanced equation to determine what that molar ratio is. Okay, so I always take the number of moles into account in the step here. That stoichiometry is always done in a separate step. And this mass is always based on 1 mole. Okay, I only ever calculate it for 1 mole when I do this. And one of the things that you'll note is that as time goes by, I'll start calculating it here. So I'll start putting 196.967 grams per mole here, and then I'll put 303.326 grams per mole there. Okay, and that way I'll have those molecular weights to work with. Okay, if I do all of this happy math, all the happy math, then that should tell me what I'm looking for. 1.000. I divide that by 196.967. I multiply it by 2. I divide it by 2. Sorry. Multiply by 2, divide by 2. And then I divide by, or not divide by, sorry. I multiply by. Go back. Multiply that by multiply and divide by 2. And then multiply by 303.326. And that lovely number that I get, the 1.53 and change, is the number of grams of AuCl3 that I get out of this. Now the question becomes, how many sig figs should that number have? Well, if I look at the numbers that I started with, I see this has 4 sig figs here and 4 sig figs here. And my answer should also have 4 significant figures. And so 1.53, and actually it's going to round to 540. Because I need to round up, and so my 5399 is going to round up to 540 grams of AuCl3. Okay, so that's 4 significant digits from that. Now, could I have predicted what my limiting reagent was? Well, no, I don't think I can. Do I know what it is? Not yet, because I've only calculated it for one of these things. So I don't know yet what the limiting reagent is. Now, do I have a guess? I can guess all I want. So I could say that I think it's going to be the gold. I could say that I think it's going to be the chlorine, but I have no way of knowing which way it's going to be. Could be either. The only way I'm going to know for sure is if I calculate it both ways, because it could be either reagent. So what we need to do at this point is use the other reagent as our calculation to see if it's that one. So I need to set up the same calculation using the amount of chlorine. So we do the same thing with our amount of chlorine. So 2.000 grams of Cl2. I know that 1 mole of Cl2 is actually, calculator go, 2 times Cl is over here somewhere. There we go. 35.453 again. So 70.906. .906 grams. So we cancel that grams of Cl2. That gets me to moles of CO2. I know that there are 3 moles of Cl2 used to make 2 moles of AuCl3. That's that molar ratio to get me out of moles of Cl2 and into moles of AuCl3. We need to know that. Okay. And then to get out of moles of AuCl3 and into grams of AuCl3, I need to divide by that. And oh, darn it, I need to check that calculation. No, never mind. I did that right. Hold on, I'll explain what I did in just a second. One mole AuCl3 is 303.326 grams of AuCl3. Now I thought that I needed to change it because there were 2 moles in the stoichiometry, but remember what I said before, and I forgot this because I was screwing myself up. We took into account the stoichiometry right here. So this is the stoichiometry from that balanced equation. It should not be here. And I tried to put it there, and it doesn't belong there. Okay, so this should not say that there are 2, because then that mass would not be appropriate. This is the mass for 1 mole, not 2 moles, 1 mole. And so it needs to reflect 1 mole. Okay? So this moles goes with this moles, that goes away. And this is one for 1 mole, and this is the mass for 1 mole. Okay. So now we do the happy math that comes from this. Here we have 2.00. We divide that by 70.906 times 2 divided by 3 times 303.326. And it gives me 5.70. 0.70. 1, 2, 3, 4 grams. And again, 4 sig figs because I had 4 sig figs to start with. And so if I look at that, the limiting reagent is the one that gives me the least amount of product. So the least amount of product that I get is from here. And so gold, that 1.000 grams of gold, produces the least amount of product. Okay, so that is my limiting reagent. So I can't predict. Nope, can't predict. The limiting reagent is AU, and I know that because least amount produced. Now I predict that I'm going to make 1.50 grams, 1.540 grams of AuCl3. And my percent yield, if I look at this, is going to be equal to my actual over my theoretical times 100. That's how we define that. So my actual yield is given as 1.042 grams divided by the theoretical 1.540 grams, and then times 100. If I look at my calculator, 1.042 divided by 1.540, enter, and I multiply that by 100, and that's 67.66, and I'm going to report it as 67.66% because it was 4 sig figs. Okay, so I'll report this as 67.66%. Move this calculator out of the way. This out of the way. 67.66%. And then it says how much of the non-limiting reagent is left over. So I'm asking you, well, how much of the excess, how much of the one that I still have, do I have left? That's an interesting question, right? Because I know I haven't used up all of that Cl2. So the question becomes, how much more do I have? Well, how do I figure that out? Interesting thing for us to talk about. So let's figure that out. So I'm going to add a new note page. And what we're going to talk about is how do we figure that out? So I know, based on what I had on the last page. Come on, go back. There we go. I'm going to copy this right here. I'm going to say I want to copy that, and I'm going to paste it over here because I can cheat. I get to do that. And I know, based on what I've done before, that this is my limiting reagent. And because it's my limiting reagent, it determines how much product I make. And so this is the one that I have an excess for, right? So if that's my limiting reagent, what I can say is that 1.000 grams of AU will determine how much of that Cl2 I need. So I can convert from grams to moles, moles to grams. Remember, that's always my process. And then I can convert from grams with the molecular weight, and that molecular weight, because it didn't all come over, I have misplaced it. $196.967. 196.967 grams of AU in 1 mole of AU. So I've again calculated how many moles of AU I have present. Great, that's awesome. Now, I know that I need 2 moles of AU, and that will then require how many moles of Cl2. So 3 moles of Cl2 are required. And so this will tell me how many moles of Cl2 would be required to react with that many moles of gold. Okay. So that'll tell me how much of my Cl2 would be required to react. Okay. And if I were to convert that to grams, that would tell me how many of the grams that I have present would be required to react. So I can go for moles, 1 mole of Cl2 being, and again, I had that mass and it's disappeared, and I love it doesn't copy it. That's fine. We can recalculate it. We have the information. We can rebuild it. So 75.453, 35.453. 35.453 is the mass of Cl. We multiply that by 2, and that gives 70.906. So this mass right here is 70.906 grams of Cl2 and 1 mole of Cl2. So again, this should calculate for me how many grams of Cl2 are required to react with all of the gold that I have. So I'm going to do that math. And again, all this is going to tell me is how much of the Cl2 is required to react with the amount of gold that I have present. Times 30 divided by 2 times 70.906. And that tells me that I need 0.53 and then actually 0.5400 grams are required. Now I know that I have more than that. I have 2.00 grams. So I take that I take that 2.000 grams minus the 0.5400 grams, and I subtract that. So 2.000 minus 0.54, and that leaves me with 1.4600 grams that are left over. That's how much I have left. So that's how much I did not consume and how much I have left over. Okay. So I have done that calculation to see how much I had left based on how much was needed and therefore how much is left from that calculation. Okay. So that's what we mean by how much is left from that material that was in excess. Okay. That's a more complicated calculation. This would be something that I would typically ask you on like an extra credit kind of thing. But that is what we're talking about when we talk about how much is left over. Okay? Questions, comments, problems on our stoichiometry review? Okay. I'm going to go ahead and take a pause here. I am going to pause here and I will come right back with you guys in a little bit. All right. Thanks, guys. I'll talk to you soon.